Moving further, let's see the resemblance of a spanner as a relational database. Like any other relational database, it has some standard features. Database contain tables with fields and data types, and you can use indexes to optimize your queries. Relationships can be used to enforce referential integrity. But there are unique differences. In a spanner, you can collocate data using interleaved tables for better performance. Interleaved tables is a powerful schema design functionality that allows you to co-locate related rows physically on a disk. This is especially useful for parent-child relationships where child rows are tightly bound to a parent. When you define a child table as interleaved in parent, a spanner stores the child rows in the same split as the parent row. This means that reads, writes, and joins involving both the tables are faster because they avoid cross split or cross node communication. A split is like slicing table into smaller chunks. Interleaving is ideal for hierarchical data like customer orders, blog comments, project tasks. Stored procedures, triggers, and user-defined functions are not supported. Now, this is a big difference compared to traditional databases and spanner. So, if you have something like stored procedure, triggers, and user-defined functions, in case of a spanner, it should go to the application layer. Now, why it is not supported? Because spanner is designed for global scalability, high availability, and strong consistency. To achieve these goals, it deliberately avoids certain RDBMS features that can increase complexity or reduce predictability in distributed environments. Moving next, you should avoid using counters as primary keys to prevent hotspotting. Now, what is hotspot? Hotspot refers to a region of the database that receives disproportionately high traffic, leading to performance bottleneck and resource contention. Now, why counters cause hotspotting in the spanner? Spanner partitions data into splits based on the lexicographic order of primary key. If your key is a monotonically increasing value such as counters 1, 2 or 3 or timestamp, this all new inserts will target the end of the key range which maps to a single split. Now what will happen? This will cause write concentration on one node. It will increase latency and reduce throughput. This defeats spanner's horizontal scalability, the very thing it is built for. So what we can use then? We can use universal unique identifier UUID or randomize strings as primary key to spread inserts across the splits. Moving next. Let's talk about spanner's distributed architecture. The spanner databases are replicated across multiple zones in a region and they can be replicated across regions for high availability. We have seen that there is 90.99% SLA for the regional implementation and we have 59 SLA for the multi-regional implementation. A spanner can scale horizontally by adding nodes to handle more data and traffic. And we have already seen that tables are physically divided into splits which are distributed across the nodes.